I left off the last example with a process and the idea of a process, but I didn't talk about the actual formula for that process. So I'm just going to write that one out here, and it's an iterative process. So for any guess, you take an original guess and then you subtract the value of the function at that guess divided by the derivative of the function at that guess. And you can find the derivation of that in your math textbook. It's based on the principle of using your derivative, following it back to the x-axis, using that one again, and so forth. So I'm just going to go ahead and use it in this next example, but if you're interested in the derivation, please take a look at your textbook. We're going to use that to estimate the root of this function. And I know you guys can plug this into your calculator and graph it and find the root, and I want to estimate this root right here. So I want to start with a guess, and if I to start with a guess, I'm really rough about it. I just say, all right, what's the function equal to at 0? It's -1. Well, let's make it a bit bigger. At f equals 1. Well, at f of 1, I get the value of -2. Let's do one more step. When x equals 2, I get a value of 3. Notice that it crossed the x-axis going between x equals 1 and x equals 2. So that means that between x equals 1 and x equals 2, I have a root. And I'm going to make my guess as halfway in between that. So my first guess, which I'm going to call x1, is going to be 1.5. Now I'm going to apply my formula for my next guess, which is based on finding the derivative and evaluating the function at my first guess. So here's the formula rewritten that I had on my last slide. I know I need the derivative, so I'm going to calculate that right away. So the derivative is 3x squared minus 2. So my second guess, notice n is now, the subscript has gone up to 2 because it's my second guess, is my first guess minus the function at my first guess divided by the derivative of the function at the first guess. So what's my function at x equals 1.5, which is my which was my first guess. So I'm just going to plug 1.5 in here and evaluate it, and I get 4.75. I'm also going to evaluate my function at 1.5, which will be -0.625. So what I'm doing is taking my x value and plugging it in here. Now I've got everything I need for my second guess. So x1 is 1.5, that was my first guess, minus the function at my first guess, which is -0.625, divided by the derivative of the function at 1.25, which is 4.75. And evaluating that, I get 1.631579. So I use this now as my subsequent guess. So now I'm going to go up one more time and go, okay, my third guess is going to be my second iteration minus the function at this evaluated at the second point divided by the second derivative evaluated at the second point. Notice that a spreadsheet would probably help here, and or if you're a computer modeler, you would do some programming to take away this tedious part. So x2, here's my x2, so I'm going to find the derivative at x2. So I'm going to plug 1.63159 into my derivative formula, and I get 5.855. I'm just going to use 3 decimal places there, 56 I should say. The function evaluated at x2, and x2 is 1.6319, is 0.00878. So now I have all three bits. I've got my x2 value, which is 1.632. I'll just round this to 3 decimal places, minus the function at x2, which is 0.000878, divided by the derivative at x2, which is 5.856. And I get a new guess as 1.618. Notice now that my third attempt at the guess, it's not changing much. It's changing now on the second decimal place. So we're accurate to within 1/10 of the root, and we could keep going to refine that. You can go up to 6 decimal place accuracies if you want to. You just have to do this process over and over again. So my root is approximately at 1.6. If